Alright everyone, welcome back. And this is our last lesson in Chapter 8. And today we're going to be learning about quadratic variation. So we've seen something similar to this before in Chapter 6. And this time it's just going to be a little bit different. And just to start off, you guys see this picture of trees growing. And I just wanted to show an example of how we see this in the real world. So the relationship between the usable height of a tree and the girth of a tree, so going around, and the volume of wood that it produces can be modeled by what we're going to learn about today, quadratic variation. Okay? So let's begin. First, we're going to talk about direct quadratic variation. So we say, if y varies directly as the square of x, then y equals kx squared. Now I know this seems like a lot of words here, but I think that once we start doing a couple of problems, you'll see really what this is meaning. Okay, so let's do this one first. Find an equation of variation where y varies directly, direct variation, as the square of x and y equals 12 when x equals 2. Okay, so we're given that y is going to equal 12, and we're also given that x equals 2. So we're looking for an equation. Find an equation. Okay, well we know that our direct quadratic variation equation will look like y equals kx squared. That's what we just defined on the previous page. So we have a y and we have an x, so we can use what we're given to solve for k, so that way we can substitute that new k that we'll solve for into the original equation, so we can find that equation. So let's just do that. So we're going to substitute 12 for y, we're solving for k, and we have 2 in for x. Okay, then we're going to have 12 equals 4 times k. Divide both sides by 4 and we get that k equals 3. So to finish off what we started, we're going to answer the actual question. It says find an equation of variation. We're going to plug that k back into this original equation, and that will be our answer. Okay. Alright, here's another example. Oops. Alright. Find an equation of variation where y varies directly as the square of x and y equals 175 when x equals 5. So we're given y and we're given x. We also know that we're looking for direct variation. It tells us that. So let's find an equation. Why don't you put me on pause and try to solve this one on your own first, and then we can go over the steps together. Alright, good luck. Alright, compare our answers. You can see here I just wrote the general formula, plugged in what was given, and I solved for k and got 7. So my final answer was y equals 7x squared. Okay, so we are just solving for an equation. We're just trying to formulate this equation of variation. Okay, now we just did direct quadratic variation. Now we're going to look at what's called inverse quadratic variation. Okay, so look here. It says, if y varies inversely as the square of x, then y equals k over x squared. Okay, so before we had y equals k times x squared, and that was direct quadratic variation. Now, instead of multiplying our k by x squared, we're dividing it by x squared, and that is our inverse. Okay, we're going to do some more sample problems with this. So, says, the law of gravity states that the weight, W, of an object varies inversely as the square of the distance from the center of the Earth. So we model this by the weight varies inversely, so equals k over the distance. And k is just a constant. Okay, it's just a number. So using this here, this is the same, pretty much the same form as what we just wrote down as our definition for inverse variation, except we just changed the variables in the context of this problem. So, it says find an equation of variation where W varies inversely as the square of D, and W equals 3 when D equals 5. So just like we did before, we're going to use what we know to solve for K, because that is what we don't know right now. And then once we have our K, we're going to find an equation of variation. Okay, so let's just write this down. And I'm going to plug in what I know. 3 equals K over 5 squared. Now the 5 squared is 25. And then I'll just write it out for us. For 25, multiply both sides by 25 and I get that K equals 75. Now remember, I'm not done yet. I have to answer the question. So I'm finding an equation. I'm going to plug that K back in and I get that the weight is going to be equal to 75 over the distance squared. And that is based on the context of the word problem we were given. Okay? And another one, we have joint variation. And what do you think of when you think of joint? Do you think of the joints in your body connecting two bones together? Two. So let's think about that. If y varies jointly as x and z, then y equals kxz. So remember before we had that y was varying inversely or directly as the square of x, or we had it varying directly here as the square of x. Now it's varying directly, or it's varying jointly for two variables. Okay? So somewhere we've seen something like this. Let's consider the area of a triangle with the height h and base. And we know this formula. We've seen this before. Area equals 1/2 times the base times height. Well, doesn't this kind of look like what we have up here? We have a value, in this case area, equals 1/2 times base times height. So our 1/2 in this equation is representing our k. And we're saying here that our area varies jointly as base and height. Okay? So that's just one place we've seen this before that you didn't even realize you already knew. Here's another problem. Find an equation of variation where y varies jointly as x and z, and y equals 42 when x equals 2 and z equals 3. So we're given a lot of information. I'm just going to write this out, our general formula, and let's just use what's given to us to plug these in. So 42 equals k times 2 times 3. 42 equals 6k. Divide both sides by 6, and I'm going to get k equals 7. Again, not done yet. My final answer will be an equation, because that is what they're asking for. And here we are. That's our final equation. Okay, so these problems don't seem too hard, and you'll find in your homework assignment tomorrow during class that you're going to see a lot of problems just like this. And the question will tell you what kind of variation we're looking for. Are we looking for joint variation, direct, inverse? Okay, so remember these formulas. Make sure you took good notes today and come into class with any questions you may have. And feel free to browse the text a little bit. See what they did. There's some application problems in there which we'll go through also in some homework problems tomorrow. All right, great job everyone. See you tomorrow.